Our first speaker today is Neil Johnson, who's with Siemens EDA. He's a Senior Product Engineering Manager. And the title of his talk is I'm Excited About Formal, My Journey from Skeptic to Believer. Neil is a long-time verification engineer with a history in product development as both a full-timer and consultant, and he now works with Siemens as a Senior Product Engineering Manager. He's responsible for QuestaSim. Just as a big thank you to Neil, he's based in Calgary, which means it's 5 o'clock for him. So thank you for getting up super early, Neil. And over to you. Thank you.
Thanks a lot, Mike. And just as a heads up, Murphy's Law has kicked in for me this morning. My headset is freaking out, so hopefully we get through the next, 25 minutes in one piece. We'll see what happens here. So yeah, thanks a lot, Mike, for the introduction. As Mike said, my name is Neil Johnson. I'm the Product Engineering Manager for QuestaSim here at Siemens. This talk is about formal verification, but I'll give you an idea of what I've done through my career in semiconductors. I started, a longish time ago. I jumped right into design. I was doing RTL design for 40 years. And then I jumped over pretty quickly to full-time into verification, which I did for about 16 years, both as a DV engineer in a few different product companies, and then for 10 years as a consultant. I've been at Siemens for about the last 2.5 years now, and somewhat ironically, I have exactly 0 years of formal experience, which, given the title, is probably a little bit odd. But we're going to start with a topic instead that I know really quite well, and that is test-driven development. So test-driven development for me as a verification engineer means that when I build a test bench, build a UVM test bench, for example, I develop and test all of the components in that test bench in isolation using test-driven development. The tests that I write for test-driven development are meant to be exhaustive for each component. They are very focused, they're very short, they run very quickly, they're automated such that they're very easy to run, so that I can run an entire unit test suite several times a day, if not several times an hour. The motivation behind test-driven development for me is all about quality. I write better code with test-driven development. Bottom line, it's not meant to add any extra bureaucracy or overhead or anything beyond that. Basically, test-driven development for me is to write better code. As far as where test-driven development fits in our usual verification paradigm, if I think about verification as usually being 2 different levels, one is subsystem level and the other is top level. Subsystem level is usually where we do our exhaustive functional testing. Top level is where we do a lot of integration testing. Where test-driven development fits in is before all of that. So for me, again, test bench components are developed and tested in isolation. When they're done in isolation, then they can be used in subsystem tests or integration tests. So with TDD, this is something that is an extra level of rigor before anything that we typically do now. As far as what test-driven development looks like, this is a cycle that is very typical, and you'll see this borrowed from software development. With test-driven development, as the name suggests, it is test-driven. So the very first thing you do with test-driven development is write a test. So again, if I'm a DV engineer building a scoreboard for my test bench, the first thing I do is write a test for some yet-to-be implemented feature of that test bench. Then I want to run that test and make sure it fails to avoid any false positives leaking into my test suite. Then I go and write that feature of my test bench, ensure the test passes, and at that point I have taken one baby step forward toward writing a fully functional and correctly functioning scoreboard. And then the next step is to add and test for the next yet to be implemented feature of my test bench. And so it goes. So test-driven development, this is the cycle that you would go through, start to finish, basically alternating writing and verifying every line of code that you write to your scoreboard. Now this talk, as the title suggests, is not necessarily about test-driven development. Where we'll go next is I'll talk about the steps I went through to learn a new but equivalent technique, basically test-driven development using formal property checking. And I think it's a technique that design engineers will find very useful when writing RTL in the style of test-driven development. So little pictures of my journey here. Basically, the first step in my journey, and this lasted about 18 years, and the first step was where I basically didn't use formal at all. Formal to me was for experts. The tools were, huge and complicated and difficult to run, and basically any formal tools were just something I never touched. Like I said, for about the first 18 years of my career. They were scary. They were scary to use. The first real step into formal came when me and a fella from our QuestaSim R&D team, we were doing some analysis on a customer design, and we found a big chunk of machine-generated code that we weren't sure was actually reachable in simulation. So after some considerable manual analysis, we couldn't quite figure it out. And so what we did was, I thought, well, we have tools that should be able to tell us this relatively quickly. Why don't I use one of these tools and see what it says? And so the tool I used was Cover Check. And one of the purposes of Cover Check is to find dead code in RTL. So running Cover Check I found to be pretty easy. You can see the scripting that's required there. It was basically 6 lines of code to run the tool, and those 6 lines were pretty much just taken from a packaged example with Cover Check. So very easy to do. The results that Cover Check delivered were pretty definitive. In this case, the machine-generated code that we were looking at was in fact unreachable. And the tool told us that in less than a minute. So, I mean, as far as being scary at this point, formal tools, at least the formal apps I found were not actually scary at all. I could use them without much trouble. So I decided to take the next step into formal, and that was into formal property checking. Now, formal property checking, I have always kind of equated with formal verification, and I have definitely found that to be scary. It sounded quite involved. Writing assertions sounded quite involved, and specifically SVA, I've always found to be fairly cryptic and not exactly easy to use. But I took this next step, realizing that Cover Check was pretty easy to use, much easier than I thought. And so I thought, well, maybe property checking is the same. So the experiment here was to take a module, a Verilog module that I was already familiar with, and all I wanted to do was write a property and prove it with prop check, which is our formal property checking tool. So this is the property that I wrote, pretty basic. I fed that property into prop check with my simple RTL module, and use prop check to prove that functionality. Surprisingly, here again, the tool was much easier to run than I thought. The interface was basically the same as Cover Check, so it was pretty easy to get going. And really surprising for me here, given that I've done almost everything I've done has been in simulation, and I'm used to writing, UVM test benches that are fairly large and quite involved, and a lot of infrastructure required. The big bonus here was effectively there was no infrastructure required. So I wrote a property. I used the bind to connect it to the module that I was testing, and that was it. So basically no infrastructure. So at this point, it's not scary anymore, and I start to think that, okay, formal property checking, this looks actually pretty useful. So I decided to take a next step. And this next step was I wanted to see if I could verify an entire module using formal property checking. And so what I did was I took that same module. I wanted to test the whole thing, and what the module did was very basic. It had a streaming AXI4 input where a bunch of video pixels were coming in. And what the module did was package up those pixels and write them into memory. A little bit of flow control here, almost not much to speak of though, but a good test for a first timer like me. So for that module, I wrote 22 properties to verify the functionality. And importantly here, it only took me a day, which I think is a critical part of this. Because again, as a person that is new to formal property check, to be able to do something somewhat useful in less than a day was pretty good in my mind. Very easy to get going. To give you an idea, now I was SVA being cryptic was something that I was a little bit leery of as I got started. Excuse me. But I found I was able to do quite a bit with just a small part of SVA. And so one of the operators that I depended on pretty heavily was the implication operator. And I'm pretty sure formal experts will tell you it's fairly integral and fundamental to formal property checking. So implication is whenever some sequence is true, then move on and prove that B is also true. I think every property that I wrote used implication. So I'm either doing something wrong or it is pretty important for formal verification. The next operator, this is a simple one. The AND operator, both sequence A and sequence B are true. And then another fairly important one was local variables. So with SVA, you have the option of a local variable inside a property. So at one point in time, you can save something in that local variable, and then later on, that local variable can be used in a check. Again, I would say I'm guessing this is maybe a slightly more advanced feature of SVA. But again, I think formal property check, formal experts will probably tell you it's pretty integral and fundamental to formal property checking. Again, I found the local variables to be very useful in the checks that I wrote. So all told, again, just to emphasize it, it took me a day to do this. I could do it with just a subset of SVA. Really impressed at this point. And not only is formal checking useful, now I start thinking that formal property checking is a really good complement to the simulation techniques that I was already very used to. And I'll admit, this is the very first time in my life I have thought this. So for me, this was a fairly big step. Excuse me. But looking back on the purpose of my journey, while I had accomplished something so far in terms of learning, I hadn't yet got to the point where I wanted to get, and that was to find some equivalent technique, similar to test-driven development, excuse me, similar to test-driven development, a technique that design engineers could use with formal property checking to write high-quality RTL. And this is the thing that I had in mind, is basically test-driven development, but you remove the simulated unit tests and you add in formal properties and formal property checking. Excuse me. So the first thing you do with property-driven development is you add a property, define a property for some yet-to-be defined feature of your RTL, feed the property into PropCheck. PropCheck should tell you that it's false to avoid any false positives. Then you write that bit of RTL, you feed the RTL and the property into PropCheck again. PropCheck should tell you that your code is good, and so it goes. Now this would be the cycle that design engineers would go through as they write RTL. So that's the step we're at here, is understanding whether or not this is possible or feasible. So to test the technique, I used a module from the same design as the last one, but I thought to be credible, it would need to be a little more complicated. So I took a module that was more complicated from that design. Still not brain surgery here, but complicated enough, I think, to validate the technique. So what this module does is it takes video frames in, and the video frames are a combination of white background cells and black pixels, white background pixels and black foreground pixels. And so those video frames go into the module. The module does some simple pixel manipulation and sends out a frame that has the same foreground pixels. It has some shading added around the foreground pixels and then the same white background pixels. So foreground and background go in, shading added around the foreground, background, foreground, and shading come out. So I followed that property-driven development cycle strictly to verify a large portion of this module. I didn't get through the whole thing, but I went far enough to understand whether or not the technique was viable. And to do that, it took me 31 properties total, and it took me a week to do. So this is a week of both developing and using formal property checking to validate the module. A week, longer than a day, but still pretty good considering this was a technique that was totally new to me. A couple of more notable SVA features here that I used. One is repetition, which I'm assuming again is pretty common. This is where you want to see the same sequence repeated multiple clocks in a row. And then there is the intersect operator, which is kind of like AND, but both your A and B sequences are the same length. But the important part here is, for me, the critical part, not the important part, the absolutely critical part here is how I ended up writing the properties while I was doing this property-driven development approach. So my starting point, kind of plan A, was to write properties, something along the lines of taking, being able to generalize all of the possible input patterns and having property or properties that validated the correct corresponding output pattern. Now, very quickly, this was going to be very, very complex, I realized. So I quickly went to plan B. And plan B involved kind of the same intent for the modeling or same intent for the property checking. But instead of modeling everything inside of an SVA, I added some RTL helper code on the side. This has been something that's been recommended to me, or I've heard it at least several times before, as a way to simplify properties. Rely on some RTL helper code to make the properties simpler. This I didn't find to be much easier in this case, actually. It might have been easier, but I didn't find that it was going to be productive. So I went to plan C, and that was more or less a divide and conquer approach along those same lines. So a series of or sets of properties that each relied on their own bit of RTL helper code again, looking to model kind of the entire possible state space and proving all of the associated outcomes. Now, as I got to this point, this is where the realization was that I understood now that I was going to end up effectively rewriting the RTL module in one form or another, a combination of helper code and properties. I did not like where this was going at all, and I think I got pretty frustrated at this point because I couldn't see a viable way to do this. And that's when the kind of the major breakthrough came to me. And I returned back to my test-driven development roots and started thinking about this more in terms of test-driven development. And so when I'm doing TDD, each of the unit tests I write has a very, very specific purpose. In fact, exactly one purpose. So I started writing what effectively were directed properties in the style of the unit tests that I would typically write. So a directed property in this case means one defined input pattern and one specific expected output pattern. And that's what you see in my property here. So the directed input pattern, this is a very specific case. You can see it in the picture up there, where there is a combination of background pixels and exactly one foreground pixel. And then I define the expected output pattern of exactly one foreground pixel, the shading around and the rest background pixels. I just went muted and unmuted. I think I'm okay now. So once I figured out this technique, this made the whole thing practical. I was able to do the property-driven development very easily now, methodical, just going through kind of one pattern at a time, as I would if I was doing test-driven development. And so that effectively was the destination I was working toward. So just to recap this last step, property-driven development, alternating writing properties and RTL, over the course of a week and 31 properties, it became apparent to me that this in fact was viable. You can still do it with just a subset of SVA, which is very encouraging. You don't need to learn all SVA. And then again, the whole key here is the directed property style of writing properties that makes the whole thing, extremely manageable, I would say, even for people that are very new to formal property checking like me. And so just to recap, formal verification for me for 18 years was for experts, and I couldn't have been more wrong. Anybody can do formal verification. A great place to start is with some of the formal apps. I started with CoverCheck. That was a good starting point for me. If I had to recommend a starting point, now that I've seen a little more from these apps, if I had to recommend a starting point, I would recommend AutoCheck. Just really easy to use and a high value outputs from that. But don't start with the formal, or don't end with the formal apps. Continue on to formal property checking, and I think give yourself a day the way I gave myself a day. Write a property, prove the property, use a module that you're familiar with to keep it easy. I think that's a really critical first step that anyone can take. And then from that point, I think like me, you'll start understanding how you can integrate formal property checking as a complement to simulation. I think that's a natural progression. And then finally, the big step here, test-driven development for me, I say this regularly, test-driven development for me is the most important skill I have learned since becoming an engineer, simply because the quality of what I produce is just so dramatically better than what I produced without. And I think property-driven development offers the same opportunity for design engineers with full verification. I would highly suggest design engineers give this a try and see what they get. And from there, we'll finish up. I think maybe we have a couple minutes for questions, or else Sarah said.
Yeah, we certainly do now.
Okay.
I'll ask those questions. First question is, well, there's a couple of questions around this actually. How many RTL bugs did you find? A, with the 22 properties in one day, and also with the ladder blocks as well.
So with the first exercise, 0. That was I used a module that I had used test-driven development previously on, so I knew it was very thoroughly tested. So that was just an exercise in understanding how to write properties.
Okay.
And then in the last one, as you're doing test-driven development or this property-driven development, you find bugs at every step, and that's kind of the key, is you find bugs at every step, and then you fix them at every step before you move on. So you always find bugs.
Okay. And would you say overall there's an increase in the quality of both the RTL and the verification?
Oh, 100%. Like I said, I think I am only here right now because I started doing test-driven development. I went from being an average DV engineer to, I would say, above average, only because of that technique, and it's only because I produce higher quality code with it. It's fundamentally it's who I am right now. Yeah.
Another couple of quick questions. Would you say it's scalable to bigger blocks and maybe subsystems?
So I would do these techniques at the module level. I would not do them at the subsystem, do them at the module level.
Okay. And I think we've now run out of time, so unfortunately, apologies to anyone who asked latter questions. I guess the lesson there is to ask your questions early, because you get to the top of the list. And a big thank you to Neil. Neil, to be honest, I think your use case is brilliant. I love your use case, and I've got some ideas of how to extend it, so I'll probably be in touch afterwards as well. But it was a very, very interesting.
Awesome.
Interesting presentation, and bang on the money in terms of how to adopt formal. So thank you very much. Thank you very much.
Thank you, Mike.